Alright, we have one more day of differentials, and what we're going to be doing today is working with this problem. And it starts out by saying that in a chemical reaction, a certain compound changes into another compound at a rate proportional to the unchanged amount. If initially there's 40 grams of the original compound, and there is 35 grams after 1 hour, when will 75% of the compound be changed? So we're talking about using the same formula we've been using. Tells me that initially there was 40 grams, so that means that C is 40. It tells me after 1 hour that there's 35 grams. So that'll allow me to be able to solve for K. So I'll divide by 40 on both sides. And I'll ln both sides, so I have the ln of 7/8 is equal to the ln of e to the k. So k is approximately negative 0.134. Now what I can do is take this and write a more specific equation, y equals 40 e to the negative 0.134 t. And it will allow me to be able to figure out when, at what time there will be 75% of the compound changed. So it says after 1 hour if initially there's 40 grams of the original compound and then there's 35 grams after 1 hour, so 5 grams of them have been changed. We want to know when 75% of the grams have been changed, so when it's down to 10. So what I'll do is I'll divide by 40 on both sides. That gives me 0.25. E to the negative 0.134 t. Then what I can do is ln both sides. This gives me negative 0.134 t. Equals the ln of 0.25, and then I can divide by negative 0.134. This answer, the ln of 0.25, is a negative 1.386 divided by a negative 0.134. So I'll divide by a negative 1.134. That gives me the time to be approximately 10.3 hours. In this next problem, it starts to talk about finding orthogonal trajectories again. Remember, orthogonal means perpendicular. So what we're going to want to do is we're going to want to find the derivative first. So I will do that with respect to x. So I'll go ahead and solve for the derivative, which gives me the slope of the line, slope of the tangent line, at anywhere on the graph. So then I get dy over dx is equal to x over 2y. Now the orthogonal trajectory means that it's perpendicular. So that means the y prime I'm looking at would be the negative reciprocal, so I'll just flip it and put a negative on it. Now what I can do is actually find the original equation by solving this differential equation. So I'll separate my variables. So I end up getting a 1/2 dy, or 1 over y dy equals, we'll keep my negative 2 over x, and I'll have dx on this side. So then I'm ready to integrate. This gives me the ln of y equals negative 2 ln of x plus c. I can e both sides at this point. That gives me that y is equal to e to the negative 2 ln x plus c. On the next video, I'll show you how to simplify that just a little bit further. So I'm going to go ahead and simplify this just a little bit further. This is the correct solution, but it may not appear in like a multiple choice type answer. So what I'm going to do is I'm going to go ahead and use log properties and actually make this say e ln x. This would be to the negative second plus c. Then what I could do is actually say, well, this is really y equals e to the ln x to the negative second times e to the c. Remember, that creates that big C. And then these actually cancel, and so I get x to the negative 2. So the equation, or the orthogonal family for this, would be y equals c all over x squared. So these two groups would end up being things that are perpendicular to each other. We've got one more of those. So we're going to go about this in the same way. I'm first going to go ahead and find the derivative. So 2y dy over dx equals, this would be 2c. So my dy over dx is actually equal to 2c all over 2y. Now we can't have c's in our dy over dx, so I need to figure out what c actually equals. So over here on the side, I'm going to say, well, c equals, when you divide by 2x on both sides, y squared all over 2x. So now I have dy over dx is equal to, I can cancel those out. I can put y squared all over 2x in for my c all over y. And now I need to simplify this a bit. So dy over dx equals y squared all over 2x, and divided by y would be multiplied by 1 over y. That allows me to cross-reduce a little bit, so I end up with dy over dx is equal to y all over 2x. Now what I can do is find that orthogonal trajectory. For the orthogonal, I'm going to flip this and make it negative because they're negative reciprocals. Orthogonal means perpendicular. And I'll say that this equals the dy over dx. The slope is negative 2x over y. So now I can find the actual original, or the general solution to this differential. I need to separate the variables first. So I have y dy, just basically cross multiplying here, and negative 2x dx. So now I'll integrate both sides, and I get y squared over 2 equals negative 2x squared over 2 plus c. Now those cancel, and I end up with getting y squared over 2 equals negative x squared plus c. Multiply everything times 2, and then I can move my 2x squared to the other side to end up with this general solution for the orthogonal trajectory.